not supposed to make sense, then not making sense is not a bug. You see what I mean? It's just basically, is the program doing what it's supposed to? But if the program has no specific task to perform, then it cannot have a bug.
Yeah, okay. I was looking at some of the obfuscated C code stuff. There was one guy that did an 11-bit preprocessor calculator that would calculate prime numbers. And then there's another guy that was like, I avoided complex statements such as for, while, do, and he just listed off all these basic control structures. It was just like, what?
Yeah, the only control structure you need is actually ternary operators and recursion.
I think he did it purely with recursion, so some large complicated piece of code, rather than using basic control structures.
Yes, because that's how Lisp and some other programming languages would have done it. Can't log in. Okay, so the for today's class, road taking is going to be electronic, because now that we have, every student has a computer, we can do that now. The passcode for today's road taking is Martian with an uppercase M, because of the movie The Martian. I just read /dot and pick something. That would be a cool password.
Is that actually out?
Yep. Well, apparently close to out. Okay. For those of you who don't know what is /dot, this is /dot.org. Okay. The name /dot is a play of the components of a URL, because usually people spell out like http://. So if you spell out this URL with the HTTP stuff, then it becomes http:///dot.org. Okay, so that's the play of the name, to confuse people. Okay, which part of the slash and which part of the dot is an actual dot as a punctuation, and which part is spelled out as DOT. So I'm hoping you guys get the joke. No, not really. Okay. But it's the original hangout place for geeks, because they have all kinds of up-to-date notes. It's usually not a full report on /dot. Somebody read it from somewhere else, but they aggregate all the news articles related to stuff that geeks should care about into one single spot. So for those of you who are really kind of curious about computer related stuff or IT related stuff, this may not be a bad place to launch into other websites, or at least from here you will also get an idea of what other websites may contain news articles that are really important to computer science or IT people.
Wow.
Yep.
Where do we enter the code for the attendance?
I think you can do it inside the attendance thing, or maybe after the class you can enter it. I don't know. It's yep.
Last time you said that you changed it to automatic, so as long as you logged in,
That's only for the last time. So for this time, it's called semi-automatic, which means you actually have to do it. I can change it to auto too. See, this one is semi-auto, and then the passcode is Martian. And because it is opened,
It says not called though.
not called? Okay, so does that mean I have a way to call them? Or I can just use auto attendance, to save some trouble. I'll just use auto attendance then. I'll figure out how to use the semi-auto, because that's ultimately what I want to do, but I'll figure that out. Okay, so I think it's auto attendance now, and you guys should be automatically attending. If you just refresh your screen, that should reflect it. Yep. Okay. So not bad. Okay. So we got this out of the way. And what we'll do today is to, I want to get you guys ready for your exam on Wednesday. I don't know whether you want to do that or not, okay? But I want to make sure that you guys are ready for the exam on Wednesday. Despite what most people think, especially my previous students tell you, which is, the exam, the purpose of the exam is to torture you so that you will, have a hard time and you'll get stumped. That really is not the purpose of the exam. The exam is an assessment, okay? I have to turn in, the final grades at the end of the semester. because you need to get a C or better to move on to the next class, and I cannot let people who are not prepared for the next class on to the next class. Why? Because tag, you're mean. You don't let people move on to the next class. Why? Come on, you guys know the answer, even though you may not want me to.
They'll have that much more trouble in the next one because it assumes that they have competent.
Because of the prerequisite, exactly. So every class builds upon the previous class. So that means, if someone is getting a D or an F in this class, that person is not going to be ready for the next class. Moving on to the next class is not going to be saving time for that person. So that's why, we need to do assessment, and exams, is one really important way that we do assessment in this class, because your grade has to reflect your academic standing, and an exam is really the only sure way that I can take care of that part. All right, so what we will do is we'll take a quick look at quick review of main concepts. Okay, there are only 9 questions in this, but I think those are important questions based on what people have been asking for the past sessions or so. Okay, so we'll go through some of these items. Now, this is by no means an exclusive list, okay, of topics that will be in the exam. The exam will include everything that we have talked about up to this point. On the other hand, I do want to show you, some of the main concepts that we have talked about up to this point. So if you have any questions about these items, today is a really good day to ask those questions, because we have the exam on Wednesday. You have 2 days to get ready. Are there any questions about the open book, open notes part of the exam? Anything that's on paper, okay, if you prepare that ahead of time on paper, you can bring it in. So that means you can work on it on your own, okay? You can work on it with somebody else as well, okay? If you have like 2 or 3 study buddies, or if you know someone who took this class in the previous semester, okay, that you think, oh, okay, I think that person can help me, go ahead, work on the paper that you will bring together, okay? That's fine. Now, remember what I said, you have to bring it has to be handwritten or printed prior to the class. So that kind of rules out the ability to write it on a piece of paper and pass on to the next person during the exam. So that would not be okay with me. Is that okay? So no passing of paper or any information of any kind during the test. Any questions? Yep.
Can you post RTFs to the forum?
Can I post?
Is it possible to post RTFs to the forum?
To the forum. You can post RTF to the forum.
Okay.
Yeah. So if you want to share your notes with the rest of the class, go ahead and post an RTF, so the whole class can have access to it. Now, just because someone is posting an RTF of something you can bring to the exam, that person is by no means guaranteeing the accuracy and correctness of that piece of paper. Do not blame that person, okay? If you cannot check the accuracy or correctness of that information, then it is your responsibility to say, well, can I use this information? Do I know this is correct? Go ahead, sorry, I kind of cut you off.
Oh, I was just thinking about trying to create like a general forum for people, posting ideas of stuff they could, and having like a class-wide RTF.
You can. I will think about doing it. I can do a wiki, but wiki doesn't work really that well, because if multiple people are editing the same wiki, the last one wins. The last person who check in wins. So that may not be the best way to do it. There's a way we can work on glossary items and stuff like that, so I can look into it. Go ahead.
You said that you had a test from previous semesters on your YouTube channel?
It's on YouTube. Yeah, you just have to find the right date. I cannot remember. But it's about the same time, so you can look into like week 6, week 7 or so. That's the time when we had the previous exam, or the exam 1 of the previous semester. Okay. Mm-hmm. All right, so let's go ahead and check out these 9 questions. They're really meant to provoke you thinking about these things, okay, and find your own answers, okay. Early in the semester, various operators are introduced. So we have introduced a whole lot of operators. There are several aspects to operators, some of which you're already familiar, okay. For instance, most operators are infix operators, which means the operator, like plus, minus, multiply, and divide, is between the values that it is operating on. All right? Are there any questions about this notation thing? Okay? Because that's the only way we learn about operators. An operator performs an operation and produces a value. So we'll take a look at this very simple expression. 3 plus 10 is called an expression because it involves one, there's an operator, and then that operator also has two values to operate on. So in return, we compute the value of 13, which is the sum of 3 and 10. That becomes the value of the expression. Every operator, or I should say every expression with an operator, has a value. That value in return can be used by another operator, can be passed as a parameter. Okay, so there are multiple uses of the value, but the most important part is every operator has a value. Are there any questions about this particular aspect of operators? Because the next slide is going to make it more confusing. Some operators also has what we call a side effect. Let's see. Nope, the next one talks about priority. So the priority of an operator indicates the ordering of evaluation. So when you see an expression like the one that we are seeing right here, 3 plus 2 times 7, which is not a very difficult expression. But the point is, most of us know that we have to perform the multiplication first. The product between 2 and 7 is then applied to the addition operator. So the result of this is not 35, because if you do it the other way, it's going to be 35 because you will be doing the addition first and then you do the multiplication. So multiplication is said to have a higher priority than addition in this case. This is just an illustration of the priority levels. Okay? So how do you know the priority levels of all the operators? There's a link in my notes to Wikipedia, and there's one table that shows you the operator priority for all C++ operators. Do you guys remember there's a link? Okay, so if you think that that might be useful to you, you can print it out and bring it along. If you think that's way too long and you can compact it and make it smaller, go ahead and make your own table and bring it to the exam. In other words, during the exam on Wednesday, I am not going to answer questions of, well, I did not bring my own sheet and this does not clearly indicate the order of operation. Which one has a higher priority? I cannot answer those questions during the exam. Is that clear? Okay, very good. All right, so the next slide talks about, this is a good one. This one talks about the side effect of certain operators. Not all, but some operators in C and C++ has side effects. Now this is something that you have to be careful about because the concept of an operator, okay, being infix, the concept of an operator has an expression has a value. The concept of the previous slide, which is operator priority, those exist in all programming languages. So it doesn't matter how or who taught you CISP 300 or 301, you should know those concepts already. This is new in C and C++. Okay? As far as I know, no other programming languages other than C, C++ derived programming languages has these type of side effects. A side effect is an effect in addition to the value of an expression. So we'll take these two as an example. This is a simple expression. It has no side effect whatsoever because in the evaluation of x plus 1, is x changed as a result? No. And then what is the value of this expression? It's whatever x has at that point plus 1. But x itself is not incremented by 1. Is that okay? Okay, so apparently this is okay. So let's move on to the next one. This is an expression. In most programming languages, this cannot be an expression. This has to be a statement. But in C and C++, this is just an expression. Okay, but as an expression, now it has its own value because remember, every expression has a value, but this one also has a side effect. What is the side effect of this statement or the expression that I have just highlighted? Come on. What is
The
what?
value of x.
It changes the value of x, so it's 1 more than what it used to be, right? But on top of that, it still has a value. What is it returning as a value? The new value of x. Okay, so the new value of x is the value of this expression. Okay, all right. So that's basically the purpose of this particular slide. And the question here is, this is a really tricky question. I'm not going to give you the answer. Okay, you have to work on it. But this is a tricky question because you have to read the symbols very carefully, because there are two symbols that look alike depending on the font that you choose to use, but there are two symbols that are very much alike when you look at them, especially from a distance, but they are different in terms of meaning. So you have to come to your own conclusion about the answer to this one. Question number 4. This is also somewhat unique to C and C++. In addition to normal operators, okay, normal operators means logical operators like and or not, and arithmetic operators like plus, minus, multiply, and divide. C and C++ also has bitwise operators. That's because C++ was used to write operating systems, including low-level code, and bitwise operators are useful for that purpose. So that's why we also have to talk about, and you have to learn about these operators. This is bitwise not, which is the tilde symbol. This is basically shift backtick at the upper left-hand corner of the keyboard. That's bitwise and, not to be confused with logical and. Bitwise or, not to be confused with logical or. Bitwise exclusive or. Exclusive or is basically doing a not the same as on an individual bit level. Okay, so you look at the two operands of a bitwise or. You look at each bit of each location, and you say, okay, bit 0 of the first operand, bit 1 of the second operand, are they the same? If they are the same, then you have a 0 at the end as the result. If they are different, then you end up with a bit of 1 in the result. That's bitwise exclusive or. Okay. There's bit shifting as well. Okay, bit shift to the right, and then bit shift to the left. Okay. So all of these operators are called bitwise operators. Shifting sometimes is not called a bitwise operator depending on the person, but all of these work on the bit level of representation of integers. So that means if you need to find out the result of a bitwise operation, most of the time, not all the time, but most of the time, you have to understand the binary representation of a value. Then you can work on the bitwise operation and then figure out the answer to that particular, or figure out the value of that expression. All right. Are there any questions about this slide? Okay. No questions. Now remember, this is me reviewing the material, so that you're ready for the exam, or more ready for the exam. Okay, after expressions, we moved on to talk about control structures. Control structures are, for the most part, kind of boring stuff because we only have a few control structures, and they are basically just the C++ way of expressing the same kind of control structure that you have already learned in cisp300 and 301. So in terms of the concepts of a conditional statement, having a then branch and an else branch, in terms of a loop having a condition to specify when to stay in the loop, and having the concept of a pre-checking loop and a post-checking loop, those should be familiar already before you get into this class. What we did in this class is to talk about the syntax that is specific to C and C++. Are there any questions in terms of the concept, the behavior of control structures? We did not talk about switch. I know some of you probably know that there are additional control structures in C and C++. I specifically did not introduce switch because one, it is not really that useful of a construct for general programming, and two, it can also lead to some problems because of the way one case can slide into another case. So that's why we are not going to talk about switch statements, at least not yet. So are there any questions about this slide? Okay. And we'll move on to question number 6. Question number 6, is about how do we read the code of C and C++ in terms of nested control structure. In other words, how do you read a program like a compiler? Okay. Are there any questions about reading a nested statement as if you are the compiler? Okay, usually the first question that most people have in their mind, they may not want to let me know about that question, but nonetheless, it is a question, is why do I need to think like a compiler? Doesn't that defeat the whole purpose of having a compiler to begin with? Well, what do you think? Why do we want to be able to think like a compiler? So that, well, go ahead, sorry.
To avoid some syntax errors.
So that we can avoid syntax errors. Well, that's what the compiler is for, is to check the syntax and make sure it is syntactically correct. So you can leave the syntax checking to the compiler. But something that is syntactically correct is not always correct. That may not be what you intend to do. That is the question, okay? So to make sure that programs are structured the way that you want, but not just look like the way you want, okay, is the reason why we have to think like a compiler. Okay? All right. So given the silent response, I'm going to give you I'll give you an example. Okay? To illustrate, first of all, the importance of understanding and be able to think like a compiler, and then two, to use this as an example. Okay? So I'll say if x is less than y, I don't know, b gets b plus 1. Okay. So let's say this is the original code. Okay, so b is a counter of some kind. Every time I get to this code, if x is less than y, I want to bump up the counter by 1. Okay? Not a problem, right? That's pretty easy. So let's say later on, in order to support another feature of this program, I also want to count the number of times when x equals to y exactly. Okay? So now I would say, now this is also syntactically okay, but it may not be, the way you want to do it. All right, so now I'm adding another conditional statement, which basically is asking, okay, if x does equal to y, I want c to be c plus 1. Okay? First of all, how do these two conditional statements relate to each other? Are they at the same level, or is one embedding the other one? They are two separate conditional statements. I would take your answer as they are at the same level. Okay, they're sequential to each other. One is not embedding or nesting the other one. Okay, then you are correct. But how do we parse something like this? Okay, well, you think like a compiler. You see the word if, and then you already set up the expectation of open paren, an expression, close paren, and a single statement. Okay? So we look for all those items. We see the open paren, we see an expression, we see the closed parenthesis, we see one single statement, because this is called an expression statement. It is an expression with a semicolon next to it. And at this point, the compiler says, I have found every single component that the conditional statement is looking for. So what it's going to do is to say, okay, I'm done with one statement, but wait, there's something else that I can look for. What is the optional component that you can potentially see after a if and then a statement? The word else, right? Because it indicates there's an else branch. Do we see an else here? No. So we see an if here. So the compiler now confirms and say, okay, the first conditional statement is now done. Okay? So this if starts the next conditional statement, which has nothing to do with the first conditional statement. But when you look at this code, some of you are really good at math, and you say, but that's okay, because x is less than y and x equals to y they do not intersect, okay? Which means, if I arrange it this way, it will still work just fine. Are we doing okay so far with that analogy, okay? But I can easily introduce a problem here. by changing this to less than or equal to. Because now, both of these conditional statements will increment both b and c if x is actually less than y. Because if x is less than y, it meets the requirement, or it will make both conditions true. On the other hand, if x is just equal to y, it will only make the second condition true, so c is the only one that will increment. But how do I fix that problem? If I want c to only increment when x equals to y, how do I fix that problem? Well, there are several ways. We can revert the change so that less than or equal to goes back to equal to, but I can also do something like this. Suddenly, the structure of this code is now completely changed, because we do not have two conditional statements that are independent or sequential anymore. One conditional statement is now embedded within another conditional statement. Does that make any sense? Because the way it works is, if you think like a compiler, it will say, okay, this is an if, the first if. It expects open paren, expression, and a then statement. We have all of those components, so I'm going to skip all the way here. But at the end of here, okay, when the compiler is at the blinky cursor, it says to itself, okay, we can optionally see an else that is corresponding to this if. And this time we did see an else. So the compiler, seeing the else, will basically say, okay, now I can expect a statement, okay? But when it's doing this, when it's expecting a statement, it sees the word if, which means the entire conditional statement, if x is less than or equal to y, c is c plus 1, is the else branch of the outer if. And that's why in this case, by introducing a single word, else, I have just changed the structure of this code quite dramatically. So the behavior of the code would also change, because if x is greater than or equal to y, only in that case I will be evaluating whether x is less than or equal to y. Is that making any sense? Okay. So getting back to my notes here, okay, the syntax rules of C and C++ is simple, but that's why it is also confusing at the same time, blah, 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 blah. So this part really has to do with, can you parse a program like a compiler and come up with the correct structure of the code? Okay, so there's an example here, and the question is not even asking what is the behavior of this code. It is simply asking, do we have a syntax error? That's the only question. Okay, and you can certainly work on this one. And don't type this program into G++ and just let C++ tell you whether it has a syntax error or not, because that would basically defeat the whole purpose. If you want to work on this one, think first, okay? Analyze this code, come to your own conclusion. Then you can use G++ to validate whether your answer is correct or not. Okay, so you can use G++ as a validation tool, but to come up with the answer, you will have to practice thinking or parsing like a compiler. Are we doing okay so far at this point? Okay, all right. I still want to go back to give you a few more examples like this kind, okay? So if I have another piece of code that originally looks like this, okay, is this syntactically correct? Looks okay, right? Because we have the if keyword, we have open paren, an expression, close paren, then we have a then statement, which is b equals b plus 1. This is the entire then statement. We have the optional else, so we need to have an else statement, which is this one here. So if I have one more thing I have to do in the then branch, and I just say, well, I'm just going to add it without anything else. So let's just say that if x is in fact less than y, I also want to know the minimum. So I'm going to say the minimum is now x. So I introduce this new expression statement into this code. So now the question is, well, if I want to make it really tricky, I will ask, what does this do? Okay, that's an extremely tricky question, because it's going to steer you into the wrong direction. Because most people will be thinking, oh, so it does something, let me see what it does. And most people will be using the indentation to help understand Okay, so now in addition to incrementing b, it will also, change m to x, but only if x is less than y. Okay, so most people will think in that direction because I steer people to that direction by phrasing the question as, what does this code do? What is the correct answer to that question?
Does it compile?
It won't even compile. Exactly, so we don't know what it does. Why won't it compile? At which point is the compiler going to choke and go like, oh, this is bad? Sorry?
There are two statements now. There are two statements.
There are two statements. Okay. So if you think like a compiler, okay, this is what the compiler is going to do. Okay, the first part is really boring because we have done this so many times. The compiler first sees the word if, sets up the expectations of open paren, expression, close paren, boring stuff. And then here's the tricky part. One single statement after the close parenthesis. Okay? So the compiler happily, just kind of goes along, open paren, cool, and expression, cool, close paren, cool, one single statement, cool. Okay? And at this point, when the compiler is right here at the blinky cursor, it will tell itself and say, well, this is a conditional statement. Optionally, there is an else, right? Do we see an else on the next line? No, the next line starts with M, which is not else. So the compiler will say, oh, okay, I have found the end of the conditional statement. This M gets X belongs to a statement that is after the conditional statement. Has absolutely nothing to do with the conditional statement other than being sequential, after the conditional statement. So the compiler doesn't have a problem parsing M equals X because it is just another statement after the conditional statement. Then it sees the word else, okay? Well, else can only be a part of a conditional statement. Am I parsing a part of a conditional statement at this point? No, I'm not. So the compiler will come back and complain and say, I'm not parsing a conditional statement. This else has no if to correspond to it. And that's why this is a compile time error. It is not a warning. The program will not compile. It will not give you the object code. There's no way to link it and run it. So that's why the answer to the tricky question of what does this code do is unknown because this program does not compile. Is that okay? So I'm revealing all the dirty tricks already so that you guys know what you will have to do to prepare for the exam. Okay? Second guessing and self-doubting is not one of those. Okay, I do not want you guys to second guess yourself during the exam. I want you to understand the concept so well that you will not have to second guess or doubt yourself. You basically say, I know exactly how the compiler works, I know exactly how it's going to see this, and this is the answer. Done. Move on. If you have any questions about these things, this is the time to ask. Are there any questions about this example? No questions? Okay, all right. So moving on to the next one. And you can see that I only describe the questions. I never really give you the answer because you can find the answer when you complete the quiz. And this is by the way, the score of this quiz does not count for your grade. It is really a part of the reading material. So it's really just one way for me to encourage you to do it in a more interactive way. And then we talk about subroutines. Subroutines they're known as functions in C and C++. So in the questions, if I use the words function, subroutine, procedure, they all mean exactly the same thing. Okay, so don't be confused if I choose to use one or the other word. Okay, they're basically the same thing. So there are two main concepts to a subroutine. Okay, all by itself without return value or or without any parameters. There are two concepts of a subroutine. The first one is invoking a subroutine. Okay, in other words, at some point of your program, when you're calling or invoking a subroutine, you are continuing execution in the subroutine. Okay, in the definition of a subroutine, that's called invocation, invoking, or calling a subroutine. Are there any questions about the terminology? Okay. But when you're inside the subroutine, when you're inside the definition of a subroutine, eventually we get to which point? There is an end of line, right?
A, right?
Well, inside a particular subroutine, you will get to the end curly brace of the subroutine itself. In other words, you run out of stuff to do in the subroutine. So now the question is, what do you do after that? That's the second main concept that is also important when it comes to subroutines. You're returning.
Yeah, you return a value type.
Well, not necessarily returning a value, but you are going to continue execution somewhere else. The question is, where are you going to continue execution?
The stack.
It's right after the invoking code. Okay? So you have an invoking code that is calling the subroutine, right? When the subroutine is all done, it will continue execution right after the invoking code itself. Is that okay so far? Does everybody kind of know what I'm talking about? Okay, let's use an example. Okay, so I'm going to give you an example that is really simple. Let's not use something that we have not talked about. So we'll just use something that we have talked about. Okay, no parameters. And it just returns a value of 5. Okay. So right now I have two kind of funky looking subroutines. Okay. One is named FIVE because it returns an actual value of 5. The other one is O because it does return a value of 0. Okay. So I'm just making funky names for these subroutines, but nonetheless, they are very simple subroutines. They return an integer value. They don't really do anything. Okay, they're not recursive in any way. There's no logic whatsoever. Okay, so now I define another subroutine called Hawaii. You guys saw that coming, right? Is that how you spell Hawaii?
Yeah, I think so.
Yeah, I think so
Plus you
too.
already have the statement.
Sorry?
Plus you already have the statement. It's name.
So what do you think it's going to return? Well, given what we have here, so it's going to say return 5 plus O. Okay. First of all, do we have recursion? I see some return with a plus statement with some calls, but do we have recursion here? There's no recursion because
None of the functions call themselves.
exactly, none of the function calls itself or anything that can potentially call itself. Okay, so in this case, we have Hawaii, returning a particular expression. All right, so let's focus on the expression that the Hawaii is supposed to return. It's 5 plus O. Okay, 5. The return value of 5 FIVE as a subroutine, and the return value of O as a subroutine. Okay, so now what are we gonna do? The first time we get to this particular statement, what do you think the computer is going to do? You have to go continue execution in 5, okay, FIVE as a subroutine, right? So, okay, fine. So we continue execution here. 5 as a subroutine has one stupid statement to execute, which is return 5, which means it specifies a return value of 5, and then it has to continue execution where?
Away.
Right after.
Oh, okay, because basically it wants to do the plus, but it can't, right? In order to do the plus, you need to know what you are adding. Right now, we have just figured out the left-hand side of the plus, so now it's time to call O so that we know what is the right-hand side of the plus. Yep.
Just to clarify how this works in my head. So when you have stack where it's first and last out. Or,
Yep.
So does it go Hawaii and then 5, or does it call O and then 5 and then it goes from 5 to O, or does it go 5 to Hawaii to O to
It goes
Hawaii?
back to Hawaii first,
Okay, yeah.
and then call O.
Okay.
Now the ordering between 5 and O can be reversed because when in addition like this, there's no guarantee that it is going to be going from left to right, but most of the time it is.
Wait, how would you know whether or not it goes left to right or not? Because that could really matter.
Yes, sometimes it does matter, and if you read the ANSI standard, sometimes they will basically tell you and say it's implementation dependent. So if something is implementation dependent, then you don't want to rely on that. You have to write your code so it does not depend on the ordering of which side gets evaluated first. Now I'm not sure whether this is one of those cases or not, but there are cases like that. I think plus may not be one of those cases. Well, in terms of structure, it is left associative, which makes sense. But that simply means how you structure the code, which does not mean how it is done, in what order it is done. So I'm not going to confuse the rest of the class. I'm just going to say, in our test, you can assume it's left to right, okay? But in reality, it may not. Okay, so the order is going to be Hawaii. Something is going to call Hawaii. Hawaii is going to call 5. 5 returns to Hawaii first to this line. Then it will call O. O is going to return to this line again. Then it will perform the addition. The sum of 5 and O will now be the return value of Hawaii, and then Hawaii is going to return to whoever called Hawaii. Is that okay so far? Yes? No? Sort of?
Yeah.
Okay, excellent. All right, so this is how functions work. When it returns at the end of a function, when it has an explicit return statement, it continues execution right after where it got invoked to begin with. Okay? Now here comes the most important part. That information, where am I supposed to go back to, is on a per invocation basis. In other words, every time you invoke a subroutine, on the fly, when the program is running, it will put something in memory to remember where it is supposed to go back to when it is done. This is part of a frame. Okay, when we ran GDB, we had those commands called BT, backtrace, and also frame. Those commands allow us to visualize what frames are, and also we can now start to understand when you call a subroutine. Okay, it maintains certain types of information, like, oh, where is the call coming from? When I'm done, where am I supposed to go back to? That's on a per call or per invocation basis. It is not static. That part is completely dynamic, on the fly. Are we doing okay so far with that concept? Because if going from this code, okay, are there any questions about this code? No questions? Okay. So going to this code, let's move on to something that's more difficult. Okay. So I'm going to call this subroutine twice, which is going to take one parameter x, and what do you think twice is going to return? 2 times x plus x. Okay. So that's twice of x, right? So now I can use another subroutine and say quadruple. Quadruple int x, and what do you think that's going to return?
Twice plus twice.
What about twice? Well, okay, there are 2 ways to do this. So I'm going to show you both ways. You can do it like this. That would do it, right? If you twice x first and then twice that, it becomes quadruple. Make sense? Okay? But there's another way to do it, which is kind of a little bit more boring, which is twice of x plus twice of x. That would do the same thing. The second way is kind of boring, so the first one is kind of more interesting. Okay, so this is one way to do it. All right? Are there any questions about this particular example between twice and quadruple? Are there any questions about calling and returning and stuff like that? Yep.
Is there any downside to using a more stack, like with having multiple?
This one does not use more stack than the other one, because the first instance of twice has to return first before you call twice again. So it's still going to use the same amount of space on the stack. Let me just explain it one more time. So the first thing it's going to do is to call twice with a parameter of x,
Okay,
right?
gotcha.
But that invocation has to come back first so that you have a value for the outer twice. So by the time you call the outer twice, which is this one, you have already reclaimed the space of the first call to twice, so you're not using any more space than the other approach. But it does have one. It calls twice exactly twice as well. I know that's confusing, but it's the same. The 2 approaches are very comparable in this case. Okay. All right. So are there any questions about this? Do we have recursion in this particular example? Is any subroutine calling itself? Using the result of twice inside another call to twice is not recursion. Okay, it is simply saying, okay, we'll invoke that subroutine first, give me a value, and in return I'll use the value again in another invocation, do the same subroutine. But is quadruple calling itself? Is twice calling itself? Then we have no recursion. Are we okay so far? Okay. Okay, I have a question. Well, with the other one, I can kind of see how 5 knows how to return back to this point, and O is going to return up to this point, and then we can do the addition, and then Hawaii can return. But in this case, in twice and quadruple, how does twice know where to go back to? Because the first time I call twice, it has to return to finish to call twice again. The second time it returns, then we can continue with the actual return statement in quadruple. So how does it know that? Well, it's because for each invocation, it remembers where to continue execution. So the first invocation to twice remembers it has to go back to evaluate the outer twice. When the outer twice returns, it knows now we can finish up the entire return statement. Okay? All right, so we'll move on to the one thing that we have seen already quite a few times. It's your factorial program. So now we have a slightly more complicated return statement, which is n is less than or equal to 0. If so, it is 1. If not, it is n times the factorial of n minus 1. All right, this one has recursion. But does it really use any mechanisms that we have not talked about? Or does it just reuse the same mechanisms that we have talked about so far? It's the same mechanism. Okay? What do we do when n is greater than 1, greater than 0? When n is greater than 0, we go to the else value. The else value is this entire expression. I don't know the value of this entire expression until I know what is f of n minus 1, right? So what I'll do is I will compute n minus 1, which does not change the value of n. Okay, this is simply giving you a value of n minus 1, and then I call f again. What is the mechanism of calling a subroutine? Okay, you guys can recite from my text or look it up somewhere else. There are several steps, right? What is the first step when you need to call a subroutine? It has to remember where to return to. What is the second thing you do? You continue execution in the subroutine that you're calling, right? So that means, who are we calling? We're calling f, okay? So that means, with a new parameter of n minus 1, we will start from the beginning, which is asking, is this new n less than or equal to 0? Okay? What if it is not? Then we go back to this point here. And what do? The first step is remember where to return to. Hold on a second here, Tag. You just said that a little bit earlier. Isn't this going to clobber what we have already remembered? The answer is no, because every time you remember where to return to, it is a separate instance of invocation, and every invocation is different or independent from all other invocations. So that's why you have frames. Okay, so basically what a frame is the return information. Where do I go back to? The parameters, the local variables, and a few other things. Okay, so collectively it is called a frame. Every invocation has its own frame. In the case of recursion, if you need to call yourself 20 times, then you have 20 frames created as a result. And every frame has its own way of returning back to the previous invocation. They may all look the same, okay? That's one option certainly, but they can all be different as well. Are there any questions about this code? I know we have been beating this horse a lot. This is not even a dead horse. It's more like hamburger now. Not a very good picture, huh? But that's a beaten horse that is beaten over and over again, and now it's grounded. So, but are there any questions? Because this is really, really important. No questions? Okay, all right. So that's basically what this slide is talking about. LIFO, last in, first out, really, really important concept. Okay, then we talked about parameters. We talked about the usual parameter. Let me go back to the example here. Is this parameter passed by value or is it passed by reference? This is passed by value. Unless you see an ampersand right before the name of the parameter itself, it is passed by value. Okay, if you see an ampersand before n, it is passed by reference. Okay. Are there any questions at this point? What is passing by reference? What do we do with passing by reference?
We pass a pointer to the address of whatever value it is, so we think.
Not pointer, reference.
Reference to.
Because pointers is kind of a different thing, you know, so we'll talk about pointers and accuracies in a different setting.
So, using a different mechanism to direct it?
It really is the same mechanism, but syntactically they're different, and what you can do with it is also entirely different. So we'll just kind of save pointers and addresses until we get to that point. So right now we just say your pass by reference is passing a way to find some storage location, some memory storage. Okay. All right. So let me test to see whether you guys really understand passing by reference as opposed to passing by value. Okay. Since I use this as an example, I can no longer use it in the test, but it will be an excellent question for the test. All right. So the typical way of doing swap or exchanging is to pass by reference. And when I specify a void as the return value type, it simply means it does not return anything. Okay. All right. So in swap, I will do the usual thing. I have a temporary variable t. T gets A gets B, and then B gets T. Okay, that's a pretty usual way of doing swap. So if you want to test out this code, you can just write your own subroutine main. Doesn't take much to test this code. Now, when you're studying for this class, it really helps to write some sample code to validate and confirm your understanding of the concepts. Okay, it's not a waste of time because the more you use G++ and GDB, the quicker you can do your next homework assignment. And this is the same kind of tools that you will have to use in CISP 400, CISP 310, and many of the other classes that you're going to take. So you are not wasting time at all by writing a 5-line program just to confirm, okay, I think this code is going to do this according to my understanding of this concept. Write some code to test it, okay, and confirm that your understanding is correct. Okay, so if I'm going to confirm this is going to work the way it's supposed to, then I'm going to say, well, we have variables x and y here, and I will be certain to give x and y different values. So one is 7 and one is 9, and then we call swap, and that's the end of the main function. Okay, so whoops, x and y. There we go. All right. So if I want to test this code, then I'll call swap, and when I get to the return 0 statement in main, x should have a value of 9 and y should have a value of 7, right? Okay, that's the way it's supposed to work, okay? Because when we use the word swap in computer science, it means to exchange the values of two things. Okay, so what I'll do is to throw a wrench into this, okay? And you guys can tell me what it is going to do then. What if I make a mistake and do this instead? One of the parameters, not both, but one does not have an ampersand anymore. What is it going to do? Well, it's not going to finish the swap for sure, right? But instead, what is it going to do? Sorry?
Just set both values the same thing.
But which one? Because we have two values. 7? Well, let's track it down, okay? So mentally, we can track down this code. Oh, I forgot one thing. This is a compile time error. Nobody bothered to mention that. Okay, because when you have parameters in the function definition, you have to pass the same number of arguments. There are ways to get around that in C++, but in this class, we're not going to use that feature. Okay, so in this case, x is used to specify parameter A. Y as an argument is used to specify parameter B. A is passed by value, which means whatever I do to A is only being done to a local copy, okay, It has nothing to do with the original thing, which is x. So x is not going to be changed. Y, on the other hand, is going to be changed because y is passed by reference. So what we'll do is we'll track down this code. Okay, the first line is saying, okay, I want to make my local variable t the same as a, but since a is x, x has 7, so t has a value of 7. The second thing we'll do is completely pointless because a equals b will change the passed by value parameter to whatever b has, and b has a value of 9. So that means the parameter a will now get a value of 9, but it doesn't change x at all because it is not passed by reference. So a parameter that is not passed by reference has its own storage, has its own memory storage, and it can store its own value independent to everybody else. Yep.
Is there a way to change whether you're passing it by value or reference on the fly as you write the function?
As you call the function, you mean?
Yeah.
No, you cannot. You can coerce a pass by reference parameter to use a temporary value, so it doesn't have to change somebody else's actual location. But the other way around is not possible. If you have a parameter in the definition that is passed by value, there's no way to change this to pass by reference. Okay. But the other one has a way to do it, but it really doesn't make sense. It can lead to a lot of potential problems. Okay, so now we're down to the last line here, which is b gets t. T has a value of what again? 7, right? And b gets 7. So that means parameter b is going to be changed to 7. No, that is not the right way to do it, or to think about it. B itself has no value. What is b as a parameter? It's a reference to somebody else. Okay, so in this case, b is a reference to local variable y of main. So whatever you do to b, like b equals t, is being done to local variable y of main. So that's why when we execute the third line of swap, the way it is structured at this point, it is going to change local variable y of main to 7. So you're absolutely right, okay? So we are not doing anything to x, y ends up with a value of 7. Okay? But that's only because I introduced an error artificially into this program by removing the ampersand that is supposed to be right before a, as in parameter a of swap. Are there any questions about this? Now, what I recommend is for you, if you think you might understand this entire program, go ahead and just copy and paste it. Okay, just write it out. This is not going to take much time, and GDB this program, and go step by step. What I want you to do is track down when it gets to this statement. Okay, do it once before and do it once after. Okay, so do it once when this is on the line that is going to be executed, and do it again when the cursor is over here. I want you to use BT, okay, well you don't even need BT because there's only 2 frames altogether. So you want to change the frame back to main and confirm that Y is already changed by the time you get to the close curly brace in swap, okay? And you also want to confirm at the same time that X is the same value 7, and you want to do it on this line because A equals B, if this were passed by reference, would have changed local variable X already. So by doing all of these GDB sessions, you're not only reconfirming or validating your understanding of the concepts, but it actually helps you understand in the process itself, because now you actually get to do it by hand, and you say, oh, main has its own frame and swap has its own frame. How do we know these are frames? Because of the command frame, right? Okay, so that gives you the context of, okay, what are we talking about? We have frame 1, we have frame 0. They're 2 different things. In frame 0, we can access the parameters a and b. In frame 1, we can access the local variables x and y of main. So that really helps to reinforce, to basically say local variables x and y belong to main, and a and b as parameters belong to swap when it is active, when it's invoked. So all of these things, and when you look at the output of BT, it also helps to understand, oh, we somehow know that this is called from this place from the caller. How does it know? Because we save that information, okay, in the frame. Are there any questions about this one? A swap subroutine that is intentionally broken. No questions? Okay. Let me see if I can. That's a question. Yep.
How large is the pass by reference value in memory?
Very little, because it really is just the address of the variable.
Yeah.
In a 32-bit platform, all addresses are only 32-bit wide. Now, it can be the address of the first byte of something that is 30,000 bytes long, but it doesn't matter because the address is still only 32-bit wide.
But there are some situations where pass by reference actually takes up more memory than the value.
Very few. Okay. One of those cases is when you just need to pass a character, and the character typically will only use 16-bit, not 8. Okay, but they use up 16-bit in the frame to represent the character. So you'll be using 32 with a 32-bit architecture instead of 16. Most of the time, for efficiency purposes, even when you even when you're passing a char, it will still use up 64 bits in the 64-bit architecture. The reason why they do that is so that everything is 64-bit aligned for the efficiency of memory access. So there are almost no cases where passing by reference can use up more space than passing by value. But it does take one more dereference to get to the answer, so it executes slightly slower, not by a whole lot. Okay, so that's question number 8, and this is question number 9, which talks about recursion. So I try my best to basically come up with a list that you can go through. If you find recursion confusing or difficult to understand, one of the following may explain it. This is not an exclusive list. Okay, you may be overthinking it. Okay, and this is actually a very common case. Okay, when I first encountered recursion in a Pascal class, I was overthinking it. It's like this is not possible because I'm still in a subroutine that is being defined. Okay, that argument does not work at all, because in order for a subroutine call to work, it only needs to know where that subroutine starts. Okay, that's it. If I call function f, I just need to know where is the starting point of function f. Oh, okay, I know where it starts. That's all I need to know. Okay, so this is the overthinking part. If you think if I call the subroutine again, then the parameters and the local variables will be corrupted, that means you did not associate these things to a per invocation basis. You're thinking local variables and parameters only exist on a per function basis, but not on a per invocation basis. Okay, getting back to the U-Haul truck example. Okay, so if a U-Haul truck is a function, okay, each invocation is one case of renting the truck. So if I rent the truck first, I can sublet it to somebody else. So now there's a second invocation. That person can in return sublet it to somebody else. So each time the U-Haul truck is sublet to another person, we have another invocation. So let's say it is stacked up 5 levels high. Okay, when the last person is done with the truck, that person is not going to return the truck to me or to U-Haul. That person will return the truck where he borrowed the truck from. Is that making any sense? And then that person, the fourth person, will return it to the third person returns it to the second returns to the first, which is me, and then when I'm done, I return it to the U-Haul place. Okay? At which point there will be no renter and the subroutine is not even getting called at that point. Is that making any sense? Sort of? Okay? So you have to remember that. Okay? Local variables and parameters are on a per invocation basis. A subroutine cannot return to itself. Okay, this is a misunderstanding. This is a myth. A subroutine has no problem returning to itself, because if the information that you saved earlier in the frame, okay, and say, oh, but this subroutine is done, return to this place. If that turns out to be the very same subroutine that you're calling, it will return to itself. That is not a problem. but it's not returning to the same invocation. It's returning to a previous invocation. Okay, that is the most important part. Is everything is on a per invocation basis. What you see as a definition is static, but when you're running it, then it's dynamic, and we can only see the invocations when you're running the code, even though we can see the definition of a subroutine. Are there any questions? Okay, because I want to make sure that everybody can differentiate between what is an invocation of a subroutine as opposed to the definition of a subroutine. The definition of a subroutine you can edit and change and view using a text editor. VI can do it, Nano can do it. If you want to download the code onto Windows, Notepad can do it. What about invocations? How can we see invocations, or more appropriately called frames? Can you look at frames just by looking at the source code of a program? No. What tool do we use to look at the frames? Starts with a G. GDB, exactly. To be even more specific, we use the commands BT and frame, okay, in order to have specific access to a particular frame, and we can use an info frame, okay, to look at the details of a frame. So that's the difference, okay. You can look at the program all you want. You can stare at the source code all you want, but you'll just be looking at the definition of a subroutine. It's only when you get to GDB can you actually see the frames while the program is running. When you have subroutines that are recursive, then you will see multiple frames, okay? And each frame is independent from the other ones. All right, so I'm hoping these 9 questions will help you out in some way to prepare for the exam. Hopefully it's not doing any worse, okay? Like, oh, this is making it even more confusing. I thought I understood this concept, but now I'm not so sure. That may not be a bad thing because we still have 2 days. Any questions whatsoever? Sorry? Oh no, it's not going to be multiple choice.
How many questions are there?
How many questions per? Oh, for the exam? I would say around 6 to 7. It depends on the difficulty, of the questions.
Can we get partial credit on those?
Many of those have partial credit. What I'm looking for are signs that you understand concepts. So if there's demonstration that you definitely understand a particular concept, then you get partial credit for that concept. But I need confirmation, of the understanding of a concept, not the absence of misunderstanding of a certain concept. There's a difference, okay? There's a big difference between those two. Okay, any other questions? Yes?
You know the free test, are you going to put the answers to that on there?
Well, we did most of it. We have only like 2 questions left to do. So let's go ahead and finish it. The other ones we did already in class. So I will just go ahead and do the last one. I think it's under control structures. Yep. Okay, so we did everything up to question number 4. So 4B and 4C are the only ones that we have not done. So I'm going to open these in new tabs. There we go. 4B. Okay, so 4B, these are you can look at these as more difficult questions. We can look at these as less difficult questions. It depends on each person, okay? Some people think it's harder to write code. Some people will think it's harder to follow my code. Technically speaking, this should be more difficult because it's not really just about following a particular mechanism. You actually have to put ideas together. Okay, so the problem is, assume that you are given several initialized variables as follows. So you don't even need to write a function, just write a snippet of code that can do the following. N is an integer value, N is at least 2. So you're guaranteed that whatever N is at least 2 and is an integer. You're also given an uninitialized variable F. Write the code to find the smallest factor of N and store that in F. Okay. First of all, what is a factor? Okay, I'll give you an example. If N is, should I use a tricky one? 91, okay? What is a factor of 91? Sorry? 1 is not a factor. 1 is never considered a factor. And by the way, 91 is not a prime number. That's why I said it's a tricky one. Come on, you guys should know what is 91.
7?
Yep, 7 times 13. So in this case, 7 would be the correct answer because out of the two factors, which is 7 and 13, 7 is the one that is smaller. Now 91, let me give you another example. 101 is a prime number. So in that case, 101 is its own factor, but 1 is not a factor. Okay, so how do we write a program like this? The code doesn't have to be pretty, doesn't have to be efficient. It just has to work. All right, so what do you do when you start on something like this? What goes through your mind? You make it, yeah, go ahead.
The smallest factor would be then 2, if you're lucky.
Yep.
So you can start by doing modulus of your variable with 2, and if it equals 0, then you have it.
All right.
Otherwise, you could move up from there.
Okay, so you are already thinking in terms of loops, modulus operator, and the condition to get out of the loop. So you're already you're formulating the solution pretty quickly. So that's good. That is a good sign. But before you actually formulate all of these things, what is occurring in your mind? Okay, slow cooker example. Ingredients. What ingredients do we need here? First thing, do it by hand a few times so that you can do it. Okay? You can never write the code to do something that you don't know how to do by hand. Trust me, I tried it. I would just bang on the keyboard and say, hey, I want a program that can do something like this. I want to know which investment to invest in so I can become a billionaire. And obviously, I have not succeeded yet. So all that bang on the keyboard every single night did not work. Yep, go ahead. Well, okay. Okay, so first thing first, okay, so we want to use an example, right? A few examples. Now, this is tricky because, well, everything is tricky in my class. Don't give yourself simple examples and do not think the computer can use heuristics the way we do. A heuristic is a rule of thumb, okay? We use heuristics all day long, okay? So I'll just use something that actually is, using a heuristic. So we'll look at 65. 65 is not a good example because everybody look at 65 and your brain automatically processes this and say, oh, it ends with a 5, so 5 is a factor. The question is it the smaller one? 65 divided by 5 is 13. 5 is less than 13, so 5 is the answer. There's no way you can easily code that, okay? So what kind of example should we use then if this is too simple? Try something like that. Because none of the heuristic that you know applies to this one. You try to look at this. Does it end with an even number? No, it's not 0, 2, 4, 6, 8. So that means that heuristic does not apply. Does it end with, if you add up all the digits, is the sum of the digits divisible by 3? That's the other heuristic. No, they do not. Right? 6 plus 5 is 11. 11 plus 3 is 14. 14 is not divisible by 3. Okay? Does the least significant digit end with a 0 or 5? No, it does not. Does the number look symmetric, like 121? No. So it's not 11. Okay, 11 cannot be a factor of this, or anything that has 11 in it. Okay, so that means all the heuristics, all the tricks that we know do not work. Now you are forced to think systematically. Okay, but even so, some people will say, I'm going to skip 2 because this is not an even number. Don't skip 2. Okay, just start with 2. So you start with 2, and then how do you know this number is not divisible by 2 or 2 is not a factor of this number?
It's not even.
Very good. So you are looking at your inventory of tools and you're locating the right tool and say, okay, out of all of these things that I have learned, okay, bitwise operators, logical operators and whatnot, ternary operators and whatnot, which one can tell me whether a number is a factor of another number? Division comes close, right? But division is not what we want. It's the modulus operator because it gives us the remainder. Very good. So you divide 653 by 2, it has a remainder of 1, and that's why it cannot be a factor. 2 cannot be a factor. What do you do next? Oh, I know this is not divisible by 3. Let's skip 3. Don't skip 3. Yep.
So when you do an incrementing
Yeah.
factor that does a conditional loop that checks to see if the remainder is equal to.
Well, it's either conditional or a loop. Cannot be both.
Okay, so it's a conditional statement that's inside a loop. That
Well, a loop has a implied condition because that's the condition to stay in the
So
loop.
basically, you increment it until the remainder equals 0. Right?
Very good. Okay, so I like what you just said. Can you say that again?
So you would increment one of the placeholders, and you would do that operator until the remainder
Yep.
equals 0.
Okay, now this simple statement is pretty much the entire program. Okay? Well, besides, not it doesn't have the initialization, but that can come later. Okay? What does the word until implies in terms of programming terms? Looping. Okay, we're doing something repetitively. Okay, so that's good. So I'm just going to highlight these things here. So we have a loop of some kind. We have increment, and what are you incrementing out of the question here? What are you incrementing? Can I change the nature of the question and change n instead of f? That doesn't make any sense, right?
And it's factor?
No, n is the integer of which I want to find a factor.
Oh, okay.
So what am I incrementing? There's only one other number, f. That's right, okay? So we know we have to increment f somewhere. We have to check the remainder, right? So that means we have to use the result of a mod and compare 0 against it, right? What am I modding? Whenever you use a mod, you have to identify what is the dividend and what is the divisor. What do you think? We only got two numbers.
So the divisor is f, and the dividend is x, which is 60.
Okay, so that's what you want because it follows the same order as a division where the dividend is the first number and then the divisor is the second number. So very good. So you have worked out all of these ingredients. Okay, all the things that we have learned so far, those are the ingredients. Do not think in terms of syntax of C. Don't let the syntax of C get in the way of putting the ideas together. Okay, always think in terms of logic first. The syntax can come later. Okay, all right. So how do we want to arrange all of these things here? Well, first of all, when we deal with a loop, it can be a pre-checking loop or a post-checking loop. So do we want to check the condition first or check the condition later?
Check the condition first.
All right, so we'll check the condition first. So we have while, and if you check the condition first, how do we want to do the comparison? Because n mod f being 0 is when we want to get out of the loop, right? But the condition of a while loop is what you want when you want to stay in the loop. That's not equal to 0. Very good. Okay. While this is happening, what do we want to do in the loop? We already have it here. Something that we're doing again and again and again. Yep, exactly. So you are pretty close. If someone turns in this code, it will just be a minor deduction because of one little issue. Okay, because f is not initialized. So what should I initialize f to? What is the smallest possible factor?
0.
2. No, 2. Because if you put 0, you're going to have division by 0. So you just need that. That's the answer. That's the solution. Okay? But since this is a mock test, the most important part is not the actual solution itself, but how did we get to the solution? Okay? So it is important to have all of your tools available. So studying helps. Okay? I know some people are really smart, they get all the concepts already, but knowing the concepts and understanding the concepts is not going to be sufficient. You have to know it well, so when you are required to construct code, you can go through all the list of tools that are available quickly and say, oh, I think I need this, this, and this, and this. Put it all into the same bin, okay? Then you can kind of work out everything in the bin itself. There's one more question. Yep.
Is this recording?
I certainly hope so. Yes, it is. If you have a class to go to, that's okay, but I think this class Oh, I was looking at that clock. It is off. Okay, it is the end of the class already. Since it's recording, I will just go ahead and finish this. But if you have another class to go to, you are excused. Okay, I'll just push the video online. You can watch this later. But for those of you who can kind of stay here a little bit longer, I'm going to finish this one. Okay, this is 4C. Assume that you are given several initialized variables as follows. N is an integer value, n is at least 1. You're also given an uninitialized variable f. Write the code to find the smallest value of f so that f factorial is greater than or equal to n. For instance, okay, if I give you, okay, let's say n is 100. Okay, so if n is 100, I want f factorial to be the smallest value that is, so that f factorial is greater than or equal to n. So how do you do it? You try 1 factorial, right? 1 factorial is, yep, go ahead.
As going down the same path, I was going to say, you do factorial in kind of reverse order, where instead of picking a value and going down, you start from the bottom and climb up until the value you have is larger than n.
Right, exactly. So what you need to do is to have, you need another variable to do this because you need to track it, or you can define a function. You can define a factorial function and just keep calling that function, right? So there are 2 ways to do that part, okay? But you do have to keep track of f factorial. So the actual solution to this one is this. So assuming you can define a new variable x, okay? So we basically say x is the factorial of 1, and the f is 1, so f factorial is 1 here. So you basically say, I will stay in the loop as long as n is less than x, because x is representing the factorial of f. If I stay in the loop, which means n is still less than x, oh, that's the other way around. No, n is, this is the other way around. If n, which is the number that is given, is greater than the factorial of f, which is represented by x, then what do? We say f is f plus 1, right? If I know the factorial of f is x, what is the factorial of f plus 1? Okay, let me, yep. So the next factorial is the O factorial times f. Okay, that's it. That's the entire program, by the way. Now, your answer doesn't have to be clean, doesn't have to be optimal. It can involve some unnecessary calculation. As long as it is correct, you will still get full credit. Okay. But on the other hand, if you miss some of the initializations, okay, for instance, if you miss the initialization of f or x, then you'll get some points taken off because it's missing some important ingredients. Sorry?
I think that's the question.
The question is asking for a value f, so that find the smallest f so that f factorial is greater than or equal to n. So you try 1 factorial. Okay, let's say n is 100. Okay, so you say, okay, let me try f being 1. Okay, 1 factorial is 1. That doesn't meet the requirement. Let's try 2. So f equals 2. Then you compute 2 factorial, which is 2. 2 is less than 100, doesn't meet the criteria. Then you try 3. 3 factorial is 6. 3 does not meet the criteria. 4 factorial is 24. 24 is less than 100, does not meet the requirement because I need something that is at least as big as 100. Okay. Then I try 5. 5 factorial is 120. So then I say, oh, 5 factorial is 100, so 5 meets the requirement. But because I scan the numbers from low value to high value, this is also the least value whose factorial is greater than or equal to n. Okay? So the key to come up, yeah.
One is keeps on incrementing right there. If you say you just get 1, then you go to the next number, which is 2.
That's the whole nature of a loop. Is basically when you look at the word while, you can say as long as. Okay? So this is basically saying as long as the requirement is not met, which is n is greater than, which is x. which is x is greater than or equal to n. Okay, so this is the reverse, which means if this condition is true, the requirement is not met. Then we'll do the following. Okay, we'll add 1 to the number itself, but we'll also have to update its factorial. But if I know the factorial of the previous number, then I know the factorial of this new number is going to be the factorial of the old number times the number itself. Because n factorial is n times the factorial of n minus 1. I'm using the same trick, except this is not recursion, this is being done in a loop. Okay? But the most important part is not to focus on the solution here, because you are guaranteed that I won't ask the same question again. So the most important part is to think of the process of thinking of coming up with a solution. Okay, you have to know all the ingredients that we have talked about, and then you have to. The most important part is to identify the key components. Okay, you throw all the components into a tray. Okay, to come up with a design. Then you say certain things can only go with other things. So that means the components will start to coalesce. Okay, it start to form shapes and things. At certain points you will have a choice. It's going to like okay, this can go here or go here. Then you have to think about which way it goes. But you have to think in those terms, and you have to be able to solve the problem by hand first. If I give you the problem and I say, okay, work this out on a piece of paper, don't give me the algorithm, don't give me the code, just give me the answer. Do you know how to come up with the answer in a systematic way? That is also important.
Following your program, what you're writing is a little bit easier for me than maybe trying to come up on a program.
Okay, if coming up with a program is easier than the other questions, that means you may not have a thorough understanding of the mechanisms. Like recursion, okay, recursion is really a simple mechanism, but
for me, I follow what your program is, and I can be able to follow what it's all about. But to come up with something like this to help you, that's a challenging part of it.
Right. Some people think this is challenging, and some people think this is less challenging, because following my code, especially when I intend to make it tricky, can also be difficult. So go ahead and study hard and